Hey guys, there's a very interesting shift happening within the world of LLMs. We started in 2023 with significantly large language model the likes of GPT, closed models, but performing really amazing. Started with 3, 3.5, and now you have GPT-4 if you use ChatGPT. There's other big players in the market like Gemini, Gemini Pro, Gemini Advanced. There's Anthropic, there's plausible AI, and a couple of other players out in the market who can be termed as the closed model space. What we also have is the llamas of the world, the mistrals of the world, which are offering open models. However, as we are progressing into this space of LLMs and systems are getting built using large language models, one interesting pattern is emerging out. Rather than leveraging and relying completely on LLMs to give you an answer, it has been found that building a more compound system, be it in the form of augmenting via RAGs or using multiple smaller models to achieve the goal, or using specific performance goals. For example, when you type your code and you get recommendations in the next line, that's not really a large language model at play. It's probably a some model very efficiently tuned and fit for doing such kind of recommendations. So different kind of use cases are warranting different sort of system designs, and the guys at Berkeley has done an interesting job in summarizing these conversations. So what I want to do in this video is bring that up and talk about it. All right, if you have listened to me so far, great. Please continue the conversation. Please subscribe to Cafe IO for a lot of videos like this. Popping on to screen share. All right. So this is the article. I'll post a link in the description, and this is from the guys at Berkeley AI Research. They call themselves Bear, which is interesting for beer. And their article is really nailing this conversation, which I just started. And they're calling it the shift from models to compound AI systems. And if you read what is mentioned in bold is you have state of the art AI results. They are increasingly obtained by compound systems with multiple components, not monolithic models. And it's important to understand the word monolithic model because that's a direct, you know, I wouldn't call it an attack or anything, but that's direct reference to a large language model. And then they have went on and defined certain combinations of systems like LLMs working with traditional problem solver to tackle Olympiad. You have LL 60% of applications using RAG, and then tons of different options. We kind of need to understand this very deeply, why we need to have the conversation around compound AI systems. And let's go all the bullet points and see what they have to say. So the first important element is some tasks are easier to improve via system design. And essentially, if you think about it, if an LLM is X% good, and maybe you could, you know, try to triple it cost and all of that, feed all the data it needs, but you'll still be able to increase its accuracy by 35%, by 5% or something like that. It's not that you're going to get a significant leaps and bounds in most cases. Uh, However, what you can always do is do a iterative kind of an approach, which has been tried in alpha code, right? Alternatively, if you have some high value applications, you should visit the use case and the system design and see how you are relying on the design of the system rather than just the LLM. Sometimes the design itself, if done iteratively right, can help you improve the overall system and the efficiency of the LLM as well, the output that you're receiving. Second is systems are really dynamic, and this arises from an inherent flaw with machine learning models, that they are limited because they are trained on static data sets, so their knowledge base is always fixed, and you cannot constantly keep on training them, primarily because of cost and time as of now. So you almost always will need to combine these models, augment these models with different components, and the most commonly used is search and retrieval to enable the model to understand the timeliness and the freshness of the data, right, and gather that dynamic behavior of the data. So essentially, you're trying to make the model do what it is not having information of, which is also a system aspect, which is why RAG is really popular. The third element that they are calling is improving control and trust is easier with systems. So, if you think about control, and this could go around the conversations of around ethics or trying to filter a certain kind of output, trying to control hallucinations, or maybe there's some form of an inherent bias in the model that you're using which you have discovered. All of these are fundamentally difficult to control when you if you try to fix the problem inside the model. However, if you take the problem outside of the model and then try to solve it, then it becomes easier to work with the problems, and you have much more dynamic elements at play which can help you solve these problems. And finally, they're calling it as performance goals vary widely, which is interestingly critical. Like, I think I started with this whole conversation where we're talking about, you have carefully tuned smaller models and lots of different search based heuristics, and to provide immediate recommendations in code and all that. And so GPT-4 might not be a great call if you want to do, next level key recommendation. So the point here is that you need to assess your system design goals very carefully. You need to be aware of the non-functionals if you're working with some sort of an LLM, and that would be the case. Uh, Also, you could go and evaluate in some form, like, hey, I'm trying to build a chatbot which is providing real-time information. And if you always end up powering it with an LLM where the output of an LLM is directly fed into the response of the chat, sometimes the model can take 12, 15, 20 seconds, and you will have to make your user wait for it, which is not an ideal state. So for these and much more deeper conversations, I think compound AI systems are uh, really going to be the leading paradigm even as models improve. That's their hypothesis. A small touch on the AI system design space. They have different AI systems like Alpha Code, Alpha Geometry, Med Prompt, which is a very specific kind of GPT for LLMs and for healthcare and all that. And then you have different kind of setups which we can use, which are essentially from a system perspective and not like the name of a model. Definitely, there are challenges around the space. The design space is really, really vast. Even if you have a simple drag architecture, there's tons of different kinds of retrieval and language models to choose from. There's embeddings to choose from. There's vector players to choose from. So too many different probabilities around there. Optimization is a fundamentally difficult problem in there. In If you want to optimize the components within the simple RAG operation, so that is, I mean, a very well known and established part of the problem. Operationalization is even more important, essentially touching a little bit on the ML ops pieces of it. But what we are really talking about is how do you log, how do you analyze, how do you debug and do all of that. There are more emerging paradigms, as these guys are calling it. So they are quoting some framework strategies. There's DSPYs, which is kind of a composite system for LLMs, which we'll talk about in some future videos. Then there's conversation about frugal AI, like, how do you make the cost go down and stuff like that. LLM Ops is also coming out as a standalone element these days, which is really, really important. And it's like, you should be able to build your traces, you should be able to get a good and deep understanding of the capabilities that LLM systems are providing. So in a nutshell, coming back and closing the share, maybe in a nutshell, what we have to understand is that generative AI is really picking up and catching up, and there's wide variety of different capabilities that we can build using it. Essentially, NLP, which is natural language prompting. However, as we go more deeper into solving this space, we have to become deeply aware of the fact that the system element of these are not neglected. You need to think of the solution as a whole system rather than trying to have everything being solved by the LLM. And that would be the fundamental summary of this conversation and the article itself. All right, so if you have liked the video, please press thumbs up, share along in your network if you have liked it. Till next video, bye bye.